Climate change and global warming are two of the greatest challenges facing mankind today. They are primarily caused by the worldwide overconsumption of fossil fuels used to generate power. As a result, a vast amount of anthropogenic carbon dioxide emissions are produced, damaging the world that we live in. This has accelerated the research into efficient renewable energy technologies such as solar, wind, and geothermal energy. These provide potential clean energy solutions for minimizing and controlling the effects of environmental pollution, promoting a sustainable future. To this end, we aim to present to you all one of the fastest growing green energy solutions in recent years, ground source heat pump technology.
The technology operates using three entities, comprised of two separate closed loops which circulate around a central heat exchange system. The first loop, known as the ground array, is comprised of an antifreeze mixture which circulates underground by the use of a pump. This mixture draws in latent heat found underground and is used to boil the separate mixture circulating around the central heat pump. This vapour is compressed and pumped to exchange heat with the central heating system, which is distributed around the house. This refrigerant mixture is then condensed back into liquid form to begin the cycle again. The ground array loop also recycles heat back into the ground, allowing for cooling facilities during warmer conditions.
Aside from domestic applications, ground source heat pumps have been installed in a variety of facilities, ranging from small businesses to large-scale industrial plants. Ground source heat pumps have also proved useful in conditioning hospitals, schools, prisons, swimming pools, and retail outlets. During the making of this video, we visited one such popular facility in East London, Crystal. The entire building space in Crystal is heated and cooled by the vertical orientation of the ground source heat pump, including constant cooling requirement for the server room.
The initial cost of installation of the system depends on layout of the ground heat exchangers, drilling, boring, backfilling and excavation cost, size of the system, and government subsidies. Due to these reasons, the installation cost is highest among prevailing technologies. However, when it comes to operating cost, the ground source heat pumps cost the least to your pocket. This is because no fuel is used for heat generation. The motive fluid in the heat exchanger tubes is only used as a heat transfer agent and hence not consumed during the process. Moreover, the electricity consumption is limited to pumps and compressors, just like a household refrigerator, hence making the ground source heat pumps a very efficient technology.
Ground source heat pumps are proven to have fewer life cycle environmental carbon impacts compared to conventional technologies based on investigations, applications, and past research works. Nevertheless, the regional electricity fuel mix, which is the major source of emissions, significantly influences the ground source heat pumps technology environmentally. The better the regional electricity fuel mix, the less environmental emissions produced by the ground source heat pumps technology.
The future of ground source heat pump technology is expected to thrive. Future research has indicated that installing ground source heat pumps in residential and industrial applications will grow. Ground source heat pumps represent a cost-effective and efficient solution for carbon-free space heat energy generation and will serve as a means of reducing perpetual concerns surrounding greenhouse gas emissions and global warming.